Alright, let's take a look at naming aldehydes. Your aldehyde has the functional group R C double bond O H. Okay, so this carbon in each molecule where the aldehyde has the highest priority will always be the first carbon. Okay, so your aldehyde has a higher priority than the ketone, your alcohol, and amine. So this will be your last name. Or suffix, and these will all be prefixes as substituents. Okay, so the ketone will be called oxo, that double bond O. The alcohol will be called hydroxy, which is the OH, and the amine will be called amino, and that's the NH2, NRH, or NR2. Now we start naming our aldehydes by taking a alkane and removing the E and add a L, so it's alkanal if you want to think about it that way. So in this example we have 1, 2, 3 carbons. This would be propanol. This is 1, 2, 3, 4. This would be butanol. This is 1, 2, 3, 4, 5. This would be pentan, al. Okay, and we can go on hexanal, heptanal. So in naming this first one, as I said, your C double bond OH, that carbon's always number 1, 2, 3, 4. So this would be butan. If we had all saturated hydrocarbons, take off the E and add a L. So that's butan, al. That's how we derive at those. The second example, I have some substituents, 2, 3, 4. So this would be 3-bromo, 2-chloro, butan, al. Alright, in this next example, we have a double bond. Okay, so that's going to be carbon 1, 2, 3, 4. Okay, so the double bond appears between 2 and 3, so we're going to have this 2ENAL. Alright, so we have 4 carbons, so we can say that's Bu2En for the double bond, Al for the aldehyde. It's understood that the Al is always position 1. There are some older notations that write it like this, but it's understood that your aldehyde being the highest priority. Takes position number 1. Okay, I could write it that way, or I could write 2-butene-al. Okay. Here I have another one. 1, 2, 3, 4, 5. Okay. The double bond starts at carbon 3, so I can say pent 3 ENAL. Okay. Here's another larger carbon-carbon chain. And what I want to do is I want to circle the largest carbon-carbon chain that contains the aldehyde, it being my highest priority. So 1, 2, 3, 4, 5, 6, 7. Okay. And these, the chlorine and this 1, 2, 3, that propyl group, those will act as substituents. Okay. So I can say 3 chloral, 2 propyl, and I have 7 carbons, so it's going to be a hep. My double bond starts at 2, ENAL. Okay, and these high priorities are actually chlorine and CO. Those are on opposite sides, so I could say that is okay. Now I'll do an example with an NH2 group. This is 1, 2, 3, 4, and 5. Okay, so this substituent is called amino, and we have a EN on carbon 2 again. So this is going to be 5 amino pent 2 ENAL. Okay. All right, here we have a C double bond OH coming off of a ring. We call that a carbaldehyde. So we're going to give it the cyclohexane name or cycloalkane name plus carbaldehyde. So this is cyclohexane carbaldehyde. Okay, we have last example. A few more substituents. Okay, we can go through and circle our parent chain. Okay, that's going to give us 1, 2, 3, 4, 5. That's going to give us 5 carbons. Okay, so I have substituents here. I have substituents here and a substituent here. So this is a methyl. this double bond O in the presence of higher priority aldehyde is oxo, and this is a phenyl group. Okay, so I just need to put those in order. So it's going to be 4 methyl, 5 oxo, and 5 phenyl. And I have 1, 2, 3, 4, 5 carbons, and that is a pentane. A pentanal. So we have 4 methyl, 5 oxo, 5 phenyl pentanal.